All right, number 1. What is the answer?
2/3.
3 halves?
2/3.
2/4? What about number 2? 9 tenths. Number 3? 11 eighths. 8 elevenths. Yeah, this is the same one as yesterday, but hopefully it was easier today. Page 283 in the book. Sorry guys, I could only get a leg
What is she doing there?
in this. It's a leg.
I know, but look, she's like.
She's doing a handstand.
Yeah, but look.
It's not a hand.
It's an A-frame handstand, double back, flip, switch, double, positive, minus.
You're gonna switch trip.
Nick? Sean surveyed 10 classmates to find which type of tennis shoe they like to wear. Okay, got to look in this table in order to get the information we really need, okay? In addition, what the heck? In addition to this, we need to know the total number of students. So how many total students were surveyed? Approximately 10. Exactly, okay? So if we surveyed 10, and we want to know what fractions of students, on number 1 here, like to wear cross trainers, how many like to wear cross trainers? Well, there's cross trainers, and this number right here, 5.
What's cross trainers?
Cross trainers. Now notice it wants the total number of students surveyed. How many total students for students? You guys know what I'm saying.
Wait.
10. Okay, now notice this is 5 out of 10. This is a fraction. Should we simplify this fraction?
It's a hard rule.
Yes, what would we divide the top by? 5. What would we divide the bottom by? 5. Okay. I know that's tricky. What's 10 divided by 5? 2. 5 divided by 5? 1. Okay. All right, what fractions of student likes to wear high tops? Well, let's look at high tops then. High tops. This bottom one is 2, right? So the number of students that like to wear high tops? 2. Number of students surveyed, it's the same number, 10. Can this be reduced? Yes, it be reducible. 1 half?
Yes.
1/4?
Yes.
You guys thought it was going to be 4, right? What fraction of students like to wear other cross trainers or high tops? Well, let's do this with fractions, okay? This is cross trainers, right? Yeah. Cross trainers, yeah. Well, let's start with our original fraction, 5 tenths. Okay? And then if we look at high tops, it was 1/5. All right? Oh, well, let's use the original fraction. It would make it much easier. Okay? So let's use 2 tenths. Okay, now what do you guys notice about the denominators? It's super important that you realize that they are exactly the same. Exactly. They do not deviate or vary in any way or form, except for color. So if that's the case, what we're going to do is we're just going to move these 10s into 1 10 over here. Maybe that sounds confusing. It just means that the denominator stays the same. Yes. All right. Then what would the numerator be in this fraction? Mason. 7. That is correct. How do we get 7?
5 plus 2.
Yeah. See, in the middle here is a big old plus sign. Well, it wasn't very big actually. 5 plus the 2 would give you this 7 tenths. Okay. Can we simplify this? 3 1/2 No, we would not reduce it. Okay. All right. So 7 tenths of the students liked to wear either cross trainers or high tops. Explain how to find 3/10 plus 2/10. Then find the sum. How would we find this?
Same thing.
Nicholas.
Look at the see what she did there. And see if they're the
Glass.
same. Yeah.
Right? Yes.
You look at the denominator, see if they're the same. And then if they are,
Okay, wait. Let's start there, okay? So, Nick says we need to see if the denominators are the same. They are the same,
they are?
right? So, is it going to be the same?
Yeah.
It
So-
are.
And then you just add the numerators.
Just add the numerators. Very good, Nick. Which would be 3 plus 2 is 6.
5.
7.
5. Which is reduced.
Well, reduce it, right?
1/5.
Very good.
Which is 1/2.
1/2. There you go. What question? Right? Or you could look at this and there's the answers. Okay. Notice the book did not reduce right away, and that's fine because we use them here. But technically, you would want to reduce those. All right. The next is this the next page or the bottom? Next page. All right. Adding and subtracting a fraction. Okay. There's the thing with fractions. So give me a number.
8.
7.
3.
Niner.
5.
One more.
5.
Fiver. Fiver.
6.
Okay. Oh, that's it. Thank you, though. All right. Now, before we do this problem, because it's not really a problem yet, so we'll finish this in a second. Remember, we have our math ops, right? Like black ops,
But with math.
but with math. They're good. Math ops with fractions.
So black ops with fractions. Or
Very
like
good.
math ops with fractions, but like black ops with
Sorry, I spelt that wrong. Fractions, okay? Black ops with math ops with fractions. What are the 4 operations we'll be using, math ops that we'll be using with fraction? Yes. Well, give me one of them.
Negative.
That is not an op.
Minus, sorry.
Minus
Subtract.
or subtraction. Yes, Isaac. Addition. Can you guys see those okay?
Yeah.
All right.
Better
Sierra.
than- yeah.
I'm sorry? Division. Very good.
Usual.
And the final one, Jackson. Multiplication. All right. Notice, let's make this a little bit lighter for you. Yeah. Okay. Let's use this one. All right. Now look at these ones. These are the 2 that we will be dealing with today. All right? And we'll talk about these in a second, but I'm just going to introduce it to you. All right? Addition and subtraction, there is something you always, always, always need. It's always. This is how you spell it, always. It's important that you remember this word because it's always going to happen when you deal with fractions and you're adding and subtracting. You must always have, what did we call them yesterday? Commotion.
Common denominators.
Come on, denom. Come on.
Common denominators. Okay? Always. You must always have this. If you are trying to add and subtract fractions without common denominators, wrong. You're doing it wrong, all right? Do it right. And get common denominators, dang it. Yes, Mason. What?
Could you do 3/5 plus 1/5 or 3/5?
Yeah. See, notice, we
Plus-
still have an example up here, Caden, so just hold on, okay? We'll get there. All right, multiplication and division, there's something you do not always need, ever, for any reason, when using multiplication or division. Do not need. Does anyone know what it is? It's common denominators. Now you no longer need them.
Common denominator.
This is something you will need to remember on Monday. Monday is when we start doing this stuff. Okay? I can't fit the 8 in there, okay? So, sorry about that. All right, in the meantime, let's subtract this. Everyone following along, this is just an example. Subtraction. Listen, I'm doing subtraction first because I know subtraction destroys you. You see a problem and you see subtraction and you don't know whether to add or subtract. It's weird. Yes?
I know the answer.
Nick thinks he knows the answer, but he doesn't. Do you?
Yeah, it's 2 9.
Okay, well, let's explain it first, okay? If I just give you the answer, we don't really benefit, right? Why did I already put the 9 there?
Because it's the
Why would I do that? Who will tell us? Alexis.
Because they're common denominators.
Yes. Excellent. This 9 has the same exact value as this 9, so I know my denominator are 9. Excellent. All right, so how do I find my numerator? Yes, Serena.
We're going to do 7 minus 5.
Good. We do 7 minus the 5, okay? What is that equals? 2 ninths. Was Nick right? Yeah, he was close. Let's look at another example then. So everyone, but one person that wasn't paying attention, did not. Everyone else raised their hand. Okay, so I'm going to ignore that one person. Let's look at another example. Give me a number.
13.
7.
7.
13.
86.
4. 6 14.
Let's do something easy like 4.
2.
Okay.
Why not 86?
Now, what I'm going to do, okay, just pay attention. Because when I do this thing that I'm going to do, that I have not told you about yet, people are going to start getting stuff wrong, and they're going to forget math, okay? Bam.
I got it.
All right, what's my denominator?
13.
13. How do I know my denominator and the answer is 13?
Because they're common.
Because it's common. Very good. All right, now how do I figure out my numerator?
Like you're adding 7.
Yes.
So it's like
Allie.
on a number line and you're -7 and then it's a positive 4. So you kind of like, so say if you borrowed money from the bank and then if you paid $4, it would be -3.
Very good.
So it's
That is excellent. Okay. Notice the negative stays with the 7 up in here. All right. So it's -7 now plus the 4, which, like Allie said, would give you a -3.
3.
All right. How many of you are still struggling with it? Listen, I'm going to point this out because some of you are still struggling. We can use a calculator. And it is awesome. The calculator will actually do the math for you, most of it. Okay? Now, I'm going to tell you right now with calculators to beware with fractions. Because the calculator is doing it exactly like you put it in. So if you do not use the order of operations, when putting it into the calculator, it doesn't know that you want it to do the order of operations.
Can you press order?
Is this clear? It'll still multiply or divide and then subtract and add for you, but if there's something in between there, you have to tell it. All right. Listen, if you're still struggling, I need you to pay attention to this because I'm going to show you how to do this with the calculator. And then you don't have to think, is it negative? Am I adding a negative? Am I subtracting a negative? Okay? Okay, so how many of you understand that are struggling that at least the denominator is 13? Is that good? Is that okay? All right, here's the thing is once you figure out that the denominator is 13, all you've got to do is figure out the numerator, right? So in your calculator, what you're going to do is you're going to push negative, which I will have to show Sierra later, okay? Notice it's a -7, right? So -7. So you're going to push the negative button and the 7 button. This is plus, so now you're going to plus 4. And this is where the calculator really saves you a lot of work, because if you push equals, it will tell you the answer. Done.
Dude.
It turns out it will show you on your screen that it's -3. Now just put that in the numerator. Denominators, all right?
No, we don't.
Here's what we're going to do is I'm going to make this negative, a minus rather, and that negative. So it would be in parentheses. Okay? There's other examples like this, but I just need to show you this because, again, with the calculator, it's going to make it very, 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 very easy. What is my denominator for the answer? 7. Bam. Okay, once this happens, once you know that denominator is 7, just ignore these. Just ignore them. Don't pay attention to them. Don't lose your lunch over it. Okay? It's a very bad idea. Now all we're going to do, I'm going to do this with the calculator first. Some of you already know what the answer is, okay? In the calculator, what I'm going to do is I'm going to do all the numerator stuff in the calculator. So I'm going to push negative, then 4, then minus, then negative. Again, the negative on the calculator should be in parentheses, to psi. 1, 0 equals. Now it will give you the answer. Remember when we were doing this with integers, we changed this to a big fat plus? Now the calculator will do it for you. What did it give you guys by just out of curiosity? 6, right? So my answer is 6/7.
Yay.
In these examples, so we're going to start, oh man, there you go. In this first example, what is my denominator going to be? Caden, hold on to that, I want to see it.
6.
6. How do you know it's 6?
Because it says
Because this denominator is 6, and so is this one. We good? Okay. So just ignore the 6's now, right? Okay, so what we have in the top is -5 plus -5. Can we do this in the calculator?
Yeah.
Hiya! -10. Now, can this be simplified?
Yes.
Yes, it can. What would it simplify to?
1 2/3.
What in the heck? Can we just say -5/3? Okay, fine. If you want it to be a mixed number, so be it. Okay? It's either this one or this one. Okay, now, will the calculator simplify this for you?
yeah.
Yes. This next example, what's my denom?
8.
8. Very good. What's my numerator?
2.
It's 2, right?
1/4. 2 is...
Done.
No, we have to...
Very good. It must be simplified. What does it simplify to?
1/4.
1/4. Questions? Very good. We're going to start with that denominator being 12 and ignore these now. 7 minus 2? 5. Done. There's the answers. Good. Which we already saw. Record this jerk. All right. So on this one, please don't forget the negative. Because tomorrow when you correct the homework and they're like, Mr. Sal, I didn't put the negative, then it's wrong. Does that make sense? There's a huge difference between negatives and positives. Huge. It's humongous. All right, this example is just in the book. What's my denominator going to be? 9. What do I do after I know that my denominator is 9?
Add 5 and 2.
5 plus 2, bam, 7. Okay? Oh, they used a number line to confuse and destroy your life. All right, here's one of those examples with the parentheses, right? Yeah, so what Isaac is saying is that if I wanted to, I could just change this to a big fat minus, which is true. You may do that, okay? Or you can put it in the calculator. Yeah, so notice on this one I have common denominators, so still the same. All right, do A, B, C, and D. All right, Isaac is going to do A, please.
Okay, so you
Talk
know.
really loud so we can hear you.
Okay, you know
Really
you're.
loud.
Okay.
Also, you have to talk in a little bit higher pitched voice.
Okay.
No, higher. Do it.
Okay. So you know your denominator's 3 because they're both 3, and then you do your 1 plus 2 and oh. Okay, that's a 3.
Very good. Is that simplified?
Or, and it's 1.
Or 1. Excellent, Isaac. Excellent work. Would someone like to do B, please? Who would like to do B? Let's have Dave. All right, here you go, Davis. You have to do the same thing, you know. High pitch.
Okay, so since this is a negative and then this is a positive, you're adding it to it. It's kind of like it's so this is gonna be okay. And so -3 plus 1 would be -2, and then you're just gonna
Deeper, we need a higher.
put it in the denominators, and you get 2 over 7. Right?
Very, very close.
Oh yeah, negative.
Negative. Excellent, Davis. Thank you very much. Excellent work. So this is B right up in here. Who would like to do C? Julia. Julia, there we go. All right, really high pitched and loud.
Okay. How does this work? Just write it. Yeah. Okay. Okay. So you add 2/5. What? So you add. I can't do this. So you add 2/5 plus negative 2/5 plus negative 2/5, which is equal to. So you add them together and stuff. Negative. Sorry. Which is 5. Or you can't read that.
Just write it at the bottom, please.
Okay. Wait, where? Boop.
Bam! There you go. Thank you, Julia. That is excellent. And D, please. There you go.
You have to do it in a certain voice.
Of course.
Squeaky.
Really, really high pitched.
Wow! First, we're gonna do -1 plus 1.
It's getting
So it's 0. 0. And then keep the common denominator. It's 4. So it's 0. 4.
Can it be reduced?
No.
Well, kind of yes and kind of no, right? Thank you, Mason. Thank you, you four. You did that excellently. Just go to the recording, and now you'll be able to hear them. Listen, yeah. Yes, it is. On D, if Mason had just put 0 on D, would he be wrong? He would be good. It would be right. Okay? All right, that's excellent. Hold on a second. Is that better? That's very good. All right, there's the answers right up in here. Okay? Oh, this is great. We do, of course, have a word problem, right? There's your answer for each different one. This is subtraction, but most everyone. There are your answers. We're going to because it's in the pointers and how to do it, okay? Let's look at this one. This one right here. Okay? Notice there's lots of words here, and because there's lots of words, your brain gets all mixed up. By the time you get to this, at least this point, you get to that red paper and you're like, oh, I can't read. So, listen, there's a much quicker way to do this, and I'm gonna point this out to you guys because I don't want your brains to be fried after this. I want them to be fried after this one, okay? So, what we're gonna do is look at what it's asking. How many sheets of paper did Bryce use? Well, Bryce used, all we've got to do is find the numbers. He used 1/8 of a sheet, 3/8 of a sheet, and then 7/8 of a sheet, okay? So all I'm going to do is I'm going to add those numbers because it asks how many? 1/8 plus 3/8 plus 7 apes. Okay?
You say 7 apes.
No, apes. Apes. All right. Notice we're now adding 3 numbers together. Does that make any difference? No, it still means that our answer will have a denominator of 8. Okay? Then all I do is the same thing. I'm just adding the numerators. 1 plus 3 plus 7, 11. Bam.
7.
Now some of you are looking at this and, Mr. Sal, can it be simplified? Yes. If you think that putting it as a whole number is simplified. I'm not going to do the extra work. I'm going to say the answer is 11/7 and be done. But some of you are still really, really hurt over that. And so if you had it as a mixed number, it'd be 1 and 3 apes.
Mr. Shell, you're ruining my life.
Okay? Over this one, the least common denominator here, all right? So, you jerk. Okay. Notice on this one we have 13, 15. Really, since we're just looking at the denominator, we can ignore these. We just want to know what the least common denominator is. What this means is I can't just multiply 15 by 12 and 12 by 15. I've got to find the least. So what I'm going to do is I'm going to list these numbers in order. Oh, man. So I start with 15, right? I'm going to list just a few of these. Next one is 30, 45, 60, 75, okay? Yeah, some of you realize what it is, right? 12, 24, 36, 48, 60. All right, so we found it. We've got this common and these common multiples, so the answer is just 60. We don't need the fractions. We don't need anything like that. It just asks for the common denominator. Okay? Yeah, 1 over 3, and it's got a big line like this, right? Over 6. And what else is it?
Plus 2 over 3.
Plusables. 2 over 3 over 6. Do we have common denominators?
Yeah.
Yes. We does. So it's 6, right? So then at the top you've just got 1/3 plus 2/3.
It's 1.
1, 6.
So if you did that in the calculator, you could just be like 1.
Again, I'm just warning you about the calculator thing because if you put it in wrong, it's going to do it wrong. That's correct. That's why I just showed you like that. So you don't do it wrong, all right? Point for us, okay? Let's look at, I'm just going to point this out to you guys. It's just very general knowledge, and you may or may not use it, depending on if you ever go on Jeopardy, okay? So, for example, I'm just going to do this as an example. Give me a number.
15.
7 over 15. Let's do minus 2 over 15, okay? I'm just going to point this out. This is exactly the same as this. All right, notice all I've done is made these two fractions into one fraction with an operation right up in here. All right? But it works, it goes the other way. This will be very important for you guys to remember in some other grade. Possibly this grade. So give me another number.
15.
15 and 5. Yeah. Give me another one.
17.
17. Okay. All right. Notice on this fraction, 15 plus 5 over 17, I can break this up. That's what I mean by that. It can go either way. I can break this up into two fractions. 15 over 17 plus 5 over 17. The only reason I'm explaining this to you is this. That's why most of this stuff works. Okay? Is because you can combine these fractions like this. And again, I'm just going to point this out once more. It can go in this direction, but it can also go in that direction. So it works both ways.